Here, this is the half sheet review got in class on the shortened day. So we're given two propositions. I did my review. I'm eligible for a retake, which if you're my student, this applies for you directly. Write in words the converse, and I'm saying the converse of the proposition. So if I did my review, then I'm eligible for a retake would be the original statement. Converse of that, if I am eligible for a retake, then I did my review. So it's Q, then P. You have to know that combination. That will not be on your formula sheet. Inverse, not P, then not Q. If I did not do my review, then I am not eligible for a retake. Again, you need to know that this is how you find the inverse. They might just ask you for the inverse. You know those symbols. And then contrapositive is the converse of the inverse. So it is not Q, then not P. So if I am not eligible for a retake, then I did not do my review. Okay, let's go to the truth table here now. So it's off to a rough start. So that means we're doing error analysis here. So let's check some answers. We're trying to figure out this proposition here. So we're in the process. So this is and I'm just going to look P and Q. Q and R, if they're both true, it's true. Otherwise, it's false. So I'm changing this one to false. 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 False and false. Okay, so that changes quite a few there right off the bat. So I edited those. P or Q, or both P and Q. So this is true as long as at least one of them is true. So I'm going down this side. True, true, true. So or usually has a lot of trues in it. So if you see a bunch of falses, it's worth double checking. Now I can negate my steps here. So I have negation of my first column. So I have false, true, 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 false, true, true, true. And then I can negate the second column. Don't do distributive property. It works sometimes, sometimes it doesn't. We're not studying those. False, false, false. And then the last couple steps, I'm going to do this whole step at once. Right here, I don't have room to fit it there, so I'm going to put the brackets, double arrow. I'm comparing this column with this column using if and only if. So it's true if they're both true or both false. So I'm just going to look for the trues. So everything else is false because they don't. Think about this as being a double arrow reflection. You could flip it over, it would be the same. And then I'm comparing all that using a proposition. And so I'm going to put not R right here so I can see it. So we're comparing this whole mess. If this whole mess, then not R. So we're doing this. Well, again, the arrow is only false when it's true followed by false. Otherwise, it's true. Is there any significance to the final column? No, because there's nothing to compare it to. It's not all true. It's not all false. It's not a tautology. That's all you got there. Okay, other side here. Again, starting with words, and then we'll go to the truth table. This is P or Q, but not both. So we're talking about I did well on my test, or I did not prepare, but not both. Sometimes it's easier to put in either or. Either I did well on my test, or I did not prepare, but not both. Weird. You can't do well on your test and not prepare is what this is saying. Okay. So we're comparing, they're having us compare some different things, and I'll talk about if you notice what these are. So P implies Q. Again, looking at just the first two columns here for P and Q. True unless it's true followed by false. So in this case, you're just going to have a bunch of trues there. And then not P implies not Q, so or not Q implies not P. So we're going to need a not Q. False, false, true, true. Need a not P. False, 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 false. So we're comparing if, then using not Q and not P. Again, it's only false when it's true followed by false. So this is the conditional statement, and this is the contrapositive. And if you notice, when you're using P and Q and not P, the conditional and the contrapositive have the same pattern. They're actually, we just showed that the conditional and the contrapositive are logically equivalent. So if you know the conditional statement overall is factual, then the contrapositive is also true. You don't always know about the converse. So let's look at the converse and inverse statements. So Q implies R. Looking at these two columns. It's false. It's false when true followed by false, otherwise it's true. And then not R implies not Q, so this is the contrapositive again. I'm going to get me a not R over here. False, true, false. So I'm going to do not R. So if not R, then not Q. So I'm looking all the way back here at this column, so I'm really going that direction. So again, I'm looking for true followed by false. So there's one. There's one. That's it. So everything else is true. So again, what do you notice here? Logical equivalence between the converse and this is the converse, but when we negate it and flip it, if you count this as your original proposition, these two are logically equivalent. So if you negate something and flip it, you should get the same pattern as if you did it originally. This is what this is saying. So these are logically equivalent and these are logically equivalent. That's all, folks.